Hello, Math Champions. In this video, we're going to talk about some sequences. Okay, what is sequences? Means number sequences. Basically, if you see in the example given here, A, there is a sequence 2, 4, 6, 8, 10. There's another sequence here in the option in the question B, 2, 4, 8, 16, 32. I want you to pause the video now and then check what is a pattern you see in different sequences. Okay, after you figure out what is that pattern you see in that sequence A, then you go for sequence B. Go ahead and try to find, do you see any pattern? Think hard. You can do it. You can find out some pattern and come back to the video and let's discuss it. Okay. Okay, Match Champions. I hope you have gone through the sequences, taken some time, and tried to figure out what is this sequence. Or you might also be wondering, say, for example, after the last number written on the sequence, what is the next number? What is the next number that I can write after this 10, after this 32? What can I write next after that? Okay, we will be talking about all of those things, discuss those things. Why are we doing this? Is because now in a situation, let's say, before I go ahead and talk about these sequences, let me tell you where this can be useful. Okay. Let's say you are playing some game or something, and you keep one marble here, and then your friend who's playing with you, he places two marbles here like this. Then the next person's turn. So this is the first line, your line, and the second person's line is this one. And the third person has to place pebbles or marbles, touching all the marbles basically, touching all the marbles. So he is going to place like this. So if you people go on doing like this, like say 10th person or 9th person, okay, 10th person or 9th person, how many pebbles do they have to place? And totally how many pebbles will be there by the time the 10th person comes? Okay, such kind of things and all will be used in such situations is where these kind of things will be useful. Or you also would have seen some places where it's a small square, okay, and then now you have to increase the area, so you will increase it and it will become this much. Then you again have to increase, so some pattern will be happening here. So now if you keep increasing, there's some rule between this and this and this. So what is that rule? How is this area changing when you keep changing the length of this square, this particular square tile or something like that? Okay, in such situations is where you will be using sequences. Okay, this is a practical application. Now coming back to the sequences already given to us here. Now, can we find out a rule? So general rule that I would always do is try to do a subtraction or a addition, right? I will try to see. Okay, 2 plus what will give me a 4? Okay, plus 2. Okay, 4 plus what will give me a 6? Oh, plus 2 again. Okay, then the 6 plus 2 should give me a 8. I'll check whether that is correct. Oh, it is giving me. Okay, good. One more check. Okay, so 8 plus 2 is giving me a 10. Good. So the rule here is add a plus 2 to the previous one. You're going to get the next one, right? Or you can also say it's 2 times 1, 2 times 2, 2 times 3, 2 times 4. Like that also you can say. However, or you can say it's the list of, is a sequence of even numbers starting from 2. Okay, that way also you can say. Whatever be the case, okay. So we have found one pattern here. Coming to this, okay, I'll again try the addition, okay. So what happens is it's a plus 2 here. The next one is 4 plus, oh, it's not a 2 now. It's not a 2 anymore. It's a plus 4 now. The next one is a plus 8. Plus 8. Then it's a plus 16 now. Oh, what am I seeing here? Whatever number is there, that I had to add to get it. So whatever number I got, that I had to get it, right? So this could be that way. Or we could think of one more way. One more way. What is it? That is, I'm multiplying by a 2. Basically, I'm doubling this, whatever was there. I get a 4. 4 multiplied by 2. That means doubling it. 4 plus 4. Whatever is there, I'm doubling that. So the rule becomes double it. Okay, the rule becomes double the number, previous number, you get the next number. Okay. So coming to the next one, okay, if I add a 3, I will get this. If I add a 5, I will get this. If I will add 7, I will get this. If I'll add 9, I will get this. There is some pattern 3, 5, 7, 9. There is one pattern. What is that pattern? These are all odd numbers 3, 5, 7, 9. Some odd numbers, if I'm adding, like subsequent next odd numbers, that could be one way that I can come up with. That is a rule I can say. Or I could also see something. What is that? It's a 1 square is 1, 2 square is 2, 3 square is 9. 2 square is 4, 3 square is 9, 4 square is 16, 5 square is. So the rule is what? Square the number. Square of the position, or maybe, or like that, no? Square of the position. Position means the first position means 1. Position 1, 1 square. Position 2, 2 square. Position 3, 3 square. So square of the position. That's the rule. Now coming to the next one, what will happen? Plus 2 here. See, though I am trying to do plus 2 or subtraction, whatever I'm doing, if that is not fitting in, if it's not matching, I'm trying some other approach. That is also you have to see. But my first approach is always to see if it is an increasing order, I will see what can I add to get the next one. Plus 2 here. Then plus 3 will give me a 6. Plus 4 will give me a 10. Plus 5 will give me a 15. Wow. Okay, so the rule is whatever the number is, okay, whatever the previous number is, I will have to add the subsequent next number. I will have to add. Means for the first position, I had to add, for the first position, whatever that number is, n plus 1 I had to add. For the second position, whatever was there previously, with that I had to add one more, right? I had to add the next number. It's not n plus 1. Basically, I will be adding the extra number, basically. That's right. The next number. That means it's a fifth position, means for the fourth position, whatever the position, the fourth position number is, fourth position number plus 5 will give me the fifth position number, like that. So this is the rule, right? Okay. Now coming to the next one. What am I doing? 1 and 1, there is no increment at all. But this between 1 and 2, 1 plus 1 it became, right? Now 2, this plus 1, 2 plus 1 it became. From 3, it's plus 2 it became. From 5 plus 3 gives me an 8. So what am I seeing here? There is a 1, 1, 2, 3, 5, 8. Means there is a plus 1 also. See the blue color? 1, 1, 2, 3. Oh, means add the previous two numbers. Rule is add previous two numbers. Then I'll get the next number. Okay, that is a way. Now here if I see I'm adding a 7, then here it's way too high. I'm adding a 19 now. 19 I'm adding. And here I am adding really, really very high a number. That is 37 I am adding. 7, 19, 37. There is no pattern here at all. Then this is not working. So I'll have to do something else. Can I do something else? Is there something else that I can see? When I see the numbers, I get to know. I see something here. 64 is actually 4 into 4 into 4. I have noticed this number because I know that 64 is 4 into 4 into 4. 4 times 4 times 4. Okay. Does it work for this one also? Yeah, it is 3 times 3 times 3. Maybe you catch some number and then trace out whether the rule works for you. Oh, then we know the rule is whatever that is, number position, cube it. N times n times n. This is the first position, 1 cube. Second position, 2 cube. Wow, good. So here is a 5 cube. Okay, now we found the rules, right? Now let's try to find the next number. Okay, once we find the rule, it's easy to find the next number, right? Next number sequence. I'm going to do it in the red color pen, right? So the rule here is plus 2 means next number should be a 12. It's a multiplication of 2 here in the second one means it is 32 multiplied by 2 gives me 64. Very nice. Here the rule is a square of the position, n square. That's the rule. So the next position is 6. 6 position is 6 square is 36. That's the next number. Here we know that plus 5 is already done. So I need to do a plus 6. Plus 6 if I do, I'll get the next number is 21. Wow, good. So here, what is the rule? Rule, add the previous two numbers. That means 5 plus 8 is a 13 is the next number. And if I go for this, the sixth position, n cube. 6 cube is 216. Wow. So in this way, when we see a sequence, we first try to see what is the general rule, what is the general pattern. Once we know the pattern, we can find any other number of that sequence also because that rule is going to work for any number in that sequence. Only then it's called as a sequence. You cannot have, and also you can also find out whether a number is out of sequence. All the other numbers are following that rule. Some particular number is not following that rule. For example, if I give you 2, 4, 6, 7, 10. If I give like this, you can see, okay, even number, even number, even number, even number. This is not an even number. This is something out of sequence. And also it's a 2 table. 2 times 1, 2 times 2, 2 times 3. 2 times 4 should have come here. You know that, right? So you can also find out what numbers are out of sequence also. But for all of that, the beginning thing is rule is what you have to find out. Rule means it's a pattern that is followed in that particular sequence. Okay, now let's talk about some sequence here. I've taken one sequence here and let's try to find some things, okay? What is the pattern that we see here? 5 plus what will give me a, okay, 4, okay. Plus 4 will give me a 30. Very good. So it was easy to find a rule that it was plus 4, plus 4, plus 4. Okay. So whenever the rule is like addition or subtraction, whenever that is such a rule, see, in previous thing where you saw many different kinds of rules, right? Squares was there, cubes was there, multiplication was there. But then we're not talking about all the different kinds of sequences. I'm talking about only about sequences where the rule is some addition or subtraction so that you will get the next number. Such sequences are called as arithmetic sequences. See, arithmetic actually should mean addition, subtraction, multiplication, everything. But then I don't know why they have said arithmetic name only for things which is add or subtract. Okay, maybe some politics or something like that. I don't know. But however, the point is, whenever the rule is of addition or subtraction, such a sequence is called as a arithmetic sequence. Now, the above sequence is an arithmetic sequence. Now, when it comes to arithmetic sequence, whenever we introduce a new topic, we give names to certain things, right? So, the first term, okay, first of all, let me tell you what's a term, okay? Sequence is made up of terms. Sequence is made up of terms. That means the 5 is a term, 9 is a term, 13 is a term, 17 is a term, okay? So, the sequence is made up of terms. So, in the arithmetic sequence, the first term is denoted or given a name like called as A. Okay. A. And there's something called a common difference. Common difference means the difference between the current number and the previous term. That means some term is there, okay? and its previous term. Okay, let's name the terms also. How do we call terms, right? Term is there, no? We call it as by using the symbol T. So the first term is A, but the second term we call it as T2, 2 in the bottom. Third term is written as T3, like that. Okay. And nth term means we don't know which position. Such a nth term is called as Tn. Tn. Okay, this is the nth term. So that means what? This is the T2, this is T3, this is T4, this is T5. It's like this, right? And this is T1 also you can say, or you can say A also. Anyhow. Okay. So now you understood what is the terms now. Now what is the common difference? It means it is, let's say, T2 minus T1 or T3 minus T2. Basically, the one term minus the previous term. Okay. So common difference is represented by D. Right? Understand this very carefully and clearly that this D is one term Tn, okay, nth term minus the previous one. If previous means n minus 1. So common difference D is given by nth term minus the n minus 1th term, right? Tn minus Tn minus 1. Okay. So this is how common difference can be found. That means here the rule might be adding 4. But if you see the common difference, okay, D will be 9 minus 5. That will be 4. Okay. Plus 4. That's the same thing that we have found here. So common difference will be this. And the particular sequence that we see there, A is nothing but 5. What is the meaning? We're starting the sequence with 5 and having a rule of addition of 4. Then you will get this sequence. Now, if my starting term changes, my entire sequence will change. Means, for example, if my starting term is minus 1 and my common difference or the rule is plus 4, then my sequence will be what? I will start with a minus 1 plus 4 plus minus 1 plus 4 is a 3. So 3 plus 4 is a 7. 7 plus 4 is 11, right? 11 plus 4 is a 15. See, the entire thing changed. Entire thing changed just because the first term changed. Okay. So, these two things are very crucial, important things in a arithmetic sequence. Okay. A and D, both of these things are important. Okay. We'll talk about few other things in the next video. Go ahead and understand the sequences, work on different sequences or these kind, and try to find out the rules and improve your analysis skill, the reasoning skill, and then you can go ahead and learn more about arithmetic sequence in the next coming video. Until then, see you. Bye bye, Math Champions.